a mobile operating system versus an operating system that goes on a vehicle that's safety critical are different, let alone the autonomy applications that sit on top of that operating system. And I think that's where a dual use company like us can be very valuable, because we are benchmarking on the commercial side. And I think if you're only serving sometimes a DoD, you sometimes don't get that commercial benchmark. We always get like baseline to the truth. If our products are not good, we're not gonna survive as a company. Full stop. We gotta win in that very competitive global commercial ecosystem where we get no favoritism being an American company or not. So my name is Qasar Younis. I'm the co-founder and CEO of Applied Intuition. Applied Intuition is a vehicle intelligence company. That means we make software and AI that ultimately makes it onto vehicles. So that's tools, that's an operating system, and it's autonomy. We started it 8-9 years ago, and we started our DC presence probably 5-6 years ago at this point. So it's been a while as well. Based in Mountain View, California, but offices all around the country and the globe. About 1,000 people, mostly engineering. I'm a very engineering heavy company.
Amazing.
Yeah.
And tell us about your role.
Yeah, Jason Brown. I lead the government business for Applied. So based here in DC, in our DC office, we have about 110 folks purely dedicated to the government mission, but really the entire company works on government work. And we are an all-domain autonomy company at this point. So we are working with every service in the Department of Defense. We are actually expanding that government business internationally to U.S. allies, and have autonomy projects happening in all domains. So air, maritime, and land.
Let's dig in a little bit more to your background. You emigrated from Pakistan. You sold a startup to Google. You ran YC. All very impressive. What brought you to autonomy? Like, how did you end up here?
So when I was at Google, that's when the self-driving project was starting. This is in the early teens. 2011 is when Google acquired the company. And I was originally an automotive engineer. The thing that you missed was I went to the General Motors Institute undergrad, and I worked at General Motors, worked at Bosch, big tier one. And even when I was at Bosch in 2004, 2005, the early, what they call, ADAS, driver assist systems were emerging. And it's really Google that really said, hey, we can do a truly autonomous system, and that kind of sparked the interest in the space again. And then Peter Ludwig and I, my co-founder, we connected again in he was one of the founding engineers on Android Automotive, which is taking Android from the phone to the car.
That car operating system.
Yeah, exactly. And so we were just talking about this intersection of software and vehicles, and one of the big disruptions within kind of that broader vehicle intelligence umbrella is autonomy and the car or whatever vehicle driving itself. And I think what we learned after we got into the business, we started the company, was actually the dynamics that exist in automotive are the same that exist in defense, they exist in construction, mining, they exist in trucking. And then they not only exist on the land, they also exist in the air and in the sea. And so the company's just naturally expanded from there.
So you've seen a really long arc of autonomy in vehicles from, something that a generation where we almost probably wouldn't recognize it to today.
Yeah.
And I think we've been talking about driverless cars, et cetera, for, more than a decade.
Yeah.
It's suddenly starting to feel real. Like maybe tell us a little bit about that. Yes, it's
you see Waymo's like literally on the block. You can time it.
I only take Waymos now. It's incredible.
Which is like a huge fact, which so the past 10 years very much autonomy was like this almost like sci-fi, will it, won't it? It's speculative, almost like crypto. Is it?
People get excited and then they get let down, and then they get excited and then let down.
I think we're at that threshold where, the next decade is very much the productionization and proliferation of autonomy, and you can say, broadly speaking, the intelligent vehicle. And it is also the monetization of this technology. And so we, it's literally in the name, we're on the applied side of AI, and which is we take, the stuff that's been kind of conclusively built and researched and tested, and now we take it to the masses. And so the state of autonomy today is there's two, just a gross simplification, but there's two prevailing approaches. You have the Waymo approach, which is the one which is like there's no driver in the seat. And that's kind of the key hallmark. There's nobody sitting in the driver's seat. And then you have the Tesla approach, which is there is a driver in the seat. And they're just on a spectrum of the level of autonomy and the level of, say, engagement that you need from the driver. Obviously, there's no driver in the seat. The car's got to be able to do everything. So what Waymo has proven, and some other companies around the globe have proven that, hey, you can actually do that. And now it's just a matter of how do you scale that in a business model that makes sense.
Yeah.
On the Tesla approach and all the other car companies, again, I'm using gross generalizations, they've proven a business model. People will pay for Tesla FSD. And
I pay for it.
Yeah, and people will pay for it, and they're continuing to improve that product through iterative process. But it can't do everything at all times. It still needs that driver in the loop. And so the next kind of 10 years is, and I think what you'll ultimately see is like somewhat of a technical convergence, because the Tesla system is a very sensor light system. It's basically just a camera system. And the Waymo system is very sensor heavy. So it's very expensive, including the compute that sits inside of Waymo is very expensive. So it just makes it very difficult for a consumer to buy that vehicle. But as Waymo, basically makes their technology more generally available and makes it cheaper, I think you'll see it start to look more like Tesla technology, and Tesla makes it more reliable and generally more available in different domains. And without the driver in the seat, it starts looking more like a Waymo. So there's a conversion of autonomy. All of that is also, by the way, going to happen in commercial trucking, in defense, in construction, in mining. All of these vehicles are just becoming intelligent. And I think the last 10 years is just a lot of promises. The next 10 years is actually the productionization. What's happening in autonomy today, this is a gross generalization, but there's two separate approaches. One is the Waymo approach, which is, you're seeing in San Francisco, which can roughly be described as a heavy censored, expensive business model not figured out, no human in the passenger, in the driver's seat. Key point, no human in the driver's seat. The Tesla approach is a business model's been figured out, people pay for it, literally with dollars.
I pay for it.
Yeah, part of owning a Tesla. And then, but it doesn't go everywhere, and the driver needs to be in the seat because it does have disengagements, whereas the Waymo doesn't, generally speaking, has tens of thousands of miles between disengagements. And so the next, the last 10 years has been, will self-driving happen? It's speculative. It's a research problem. The next 10 years is the monetization. We're all in this, we as in the technology community who works in autonomy, nobody's wondering, is this a research problem? Now it's all on the applied side. It's taking this into production, making it cheaper, generally available. And like literally is in the name of our company, we take these things and we, on the applied AI side, and we really proliferate them through vehicle manufacturers. That's kind of our business. We work with manufacturers.
Do like more traditional U.S. auto manufacturers, like how are they going to look more like Waymo or more like Tesla, or what
definitely more like Tesla.
Got it.
And that's not only U.S. automakers. I would say all global automotive OEMs are like that. And when we say more like Tesla, just to be very hit the nail on the head, we're a vehicle intelligence company. We provide the intelligence that goes into it. What Tesla Plus looks like, and you see some of this in China, frankly speaking, with the Huawei vehicles and a couple of other kind of marquee brands there, is just a really intelligent in-cabin experience, a really intelligent driving experience, and a really intelligent connected app ecosystem, which connects to your home. And Xiaomi has these great kind of demos where, when the car comes home, the blinds kind of open, close, the heating and all of that stuff. And you can take media that's playing in your TV and then seamlessly play it on your, that interaction is just very, very smooth. Yeah. So I think that's more of the future. The Waymo stuff is really a true, it's like a ride-sharing product that ultimately is kind of a replacement for Uber for more than anything else.
Yeah, makes sense. Are you starting to see like a standard autonomy stack take shape but I guess both across your commercial and more your enterprise and maybe defense customers? Like, is there starting to be a standard set of hardware? Does that make your job easier, harder? What's the impact for applied?
So any of these advanced technologies, it's false to say that there's just a standard, but I think probably a more accurate version is the abstraction away from hardware is becoming more and more common. And what I mean by that is the autonomy system that we have running, let's say on a defense, vehicle, let's say it's a troop mover or a tank or something like that. It's like 90% similar to what we're doing on the on the commercial side and on the passenger car side or on the trucking side. And that was not the case just, a few years ago. So what's happened kind of below the hood is there have been just changes in model architectures of improvements. And so I think everyone understands the proliferation of transformers as it relates to large language models, and how kind of chatbots have gone from kind of really bad to really, really great in a short amount of time. There's a similar, let's say, paradigm shift happening in autonomy and in vision systems as well, with transformers. And so what that ultimately means in autonomy is the similar dynamics in large language models. You can put lots of data in and you get these nice scaling laws. The same thing's happening in autonomy. And people will roughly use this kind of end-to-end, terminology.
Yeah.
It's both accurate and not accurate. We don't need to get into that right now. But the point is the architectures are creating capabilities that allow autonomy to kind of scale horizontally in ways that it just didn't, let's say, even 5 years ago.
Yeah, and the approach is generally the same, right? For defense, where you need to have the same sort of approach in simulation and the tooling that you develop autonomy for the commercial side is exactly what you need to do for defense. The challenge we have, of course, is condensing and showing and demonstrating that this is critical for developing any of these autonomous solutions embedded within these vehicles in development. And the other key thing about defense is that these vehicles stay in their inventory and out in the field for years and decades.
Sure.
So many of these systems,
the lifespan of a tank is we're talking.
Yeah, I mean, the B-52 will be 100 years old.
100 years.
Here and it'll still be flying, right? And so what's interesting is a lot of these vehicles still require software to become more lethal, more mobile, more survivable. And so how do you then take all of this technology that we developed for the commercial side for vehicles that are continually being developed and employed, and then actually bring that and retrofit back into the vehicles that exist? It turns out it's similar approaches, different stacks potentially, but similar approaches on how you enhance architectures and then, bring these capabilities on even legacy systems. So this is one of the approaches we're also taking with defense customers, because we recognize that they're new vehicles are not happening every day, not happening every year. You have to figure out also how do you basically make all of these legacy systems, more capable with software.
So what's actually your balance specifically for DoD between supporting retrofits and legacy systems and helping make those extend the lifetime and make those modern versus, some new systems that are coming out and have, a different architecture that might be AI first out of the gate?
Yeah, generally it's about 50-50. So about 50% of our products are related to vehicles or autonomy that's in development, and then the 50% we're focused on, essentially legacy vehicles. And, some of these systems need to be, we use terms enhanced. That tends to be less dramatic for a lot of folks, but in reality, we have to jailbreak a lot of these systems, literally get the government to say, yeah, I know this was built by somebody else. I just need you to go in here and jailbreak this thing and show us what you can do, show us how you can actually make this a better vehicle, because it's really difficult to do it any other way than just, hand it to you and let's see what you can do.
So maybe backing up, you alluded to this, you launched your defense business in 2019, so 6 years ago or so now, before it was cool in Silicon, squarely when it was not cool in Silicon Valley to be building for defense. Why did you do that? What drove you? What drove you to build that side of the business?
So this is an A16Z, podcast, so I'll do some shilling here for promotion.
Thanks.
It was an EBC that we had, and it was General Dynamics, who had just come through the Valley and were meeting companies. And we have three pillars of our business. It's tools, operating systems, and autonomy. And we were showcasing our tools. What Jason is talking about is what autonomy really is, fundamentally, is the tools that you need to ingest this data, curate this data, make these models, and then test these models before you actually deploy them on a physical vehicle. A lot of that is just tooling, right? And it's a software factory that makes this. So that's what we're showing to General Dynamics. That resonated, at a much, much deeper level than we expected. And we just found out that, actually, the primes, broadly speaking, have the same problems that the commercial side has. And so, in 2019, I think is when we actually set up the office and we really had it. But we were working with, in the ecosystem even sooner. And then we recognized, actually, there's this whole ecosystem, right? Just it's if you're in the defense ecosystem, it's hard to imagine how diverse the automotive ecosystem is, or commercial trucking, or construction and mining. But each of these are their own economies with multiple 100 billion revenue companies. And so then as we kind of got into the defense ecosystem, we realized, there's like this direct to DoD, there's DIU, there's this whole, everything from, a PAC and setting up a DC office. And I think we just, over the last, 6+ years, we've just built a real presence within DC and almost like, a division of the company. But it's its own area of expertise. It's very different than the commercial side.
Yeah, it's very different. It's notoriously complex. It's, the procurement processes and cycles are really different. You alluded to this. So after that meeting with General Dynamics, like, how did you get your first toehold into a direct DoD engagement?
I mean, DIU obviously plays a critical role there. My memory doesn't really like
the robotic combat vehicle program with the Army was our first big one.
Yeah, exactly. It was our first big one. There's also like SIBRs that are always around.
Yeah.
So there's ways to engage with the DoD. But we were a tiny little company with under 100 people, and so you're talking about sharing resources, and that's where you're kind of gear matching. Your gears are matching. As you're a larger company, you're going to actually have folks who are fully dedicated to this and pursue larger programs of record. So I think my recommendation to founders who are out there who want to get into that kind of defense ecosystem or a dual use company is you just have to start. Mm-hmm. So you start, and there's different ways to start. And that's the way we started. It's not necessarily the way everyone has to start, but it was an effective way to just get the flywheel going.
And sorry, go ahead.
No, I was just so Qasar, do you feel like at some point, like, in the history of the company on the commercial side, did you feel like you were doing much more market shaping, and then it flipped at some point to market, like there was actually a market that then you were serving? Was there some sort of like shaping aspect? Because this is definitely where we're at on the defense side. We are absolutely market shaping up to this point. Yes. We're starting to sense all of this starting to actually shift into absolutely.
Yeah. I mean, the version of riding Waymos in SF. If Waymos had a huge presence here in DC, it would change.
Plug for Waymo to come to DC.
Yeah, which is also
a portfolio company.
Yeah. I mean, if they're here, it just changes you as you could be working
you
at
feel
SEC.
It viscerally. Yeah, you
don't have to be in autonomy, and you could be working at the Department of Education. You go in that and you're like, oh, this thing is real. Like, this is not something that's fake. I just ordered them. I didn't need any specialization. And so in terms of, I think that like us pushing to and pulling is happening because of a larger industry. A good way to think about this being autonomy is the way to think about almost like the mobile revolution, which was the last big kind of consumer revolution that happened. And imagine if the DoD was responsible for building a phone versus Apple or versus Android. And, it's very hard to imagine they can outpace the commercial side.
Yeah, you can't really design a phone with a list of DoD requirements.
Yeah, and so
at least a great phone.
So there's a similar thing in autonomy where at some point people at the DoD recognize, and the government recognizes broadly, we need to have a mobile strategy. We need to know how these devices are used, how they're fielded, both on just the regular bureaucratic day-to-day DC job, but also out, for the warfighter in the front lines. Let's think about autonomy the same way. How is autonomy going to affect the government broadly, and Department of Transportation, et cetera, but then also the warfighter? And I think it's way more complex because the technology is way more deep. Like a mobile operating system versus an operating system that goes in a vehicle that's safety critical are different, let alone the autonomy application that's sit on top of that operating system. And I think that's where a dual-use company like us can be very valuable because we are benchmarking on the commercial side.
Yeah.
So, and I think if you're only serving sometimes at DoD, you sometimes don't get that commercial benchmark. So imagine again, you're somehow a phone provider.
You get sucked into the list of requirements.
Yeah, and we always get like baseline to the truth. If our products are not good, we're not going to survive as a company. Full stop. We got to win in that very competitive global commercial ecosystem where we get no favoritism being an American company or not.
Yeah. I just want to lean into the idea that the nature of autonomy is dual use, right? So all those benchmarks are on the commercial side right now. So the DoD trying to actually develop and do a number of things without referencing, the commercial benchmarks, those who are familiar with what does it take from a ROI perspective, from a progress, and how many iterations of software do you need to actually develop before it's ready to ship? All of that currently is on on the commercial side. All that said, given that this is a dual use technology from its nature, from its core, what we've seen as a company is the kinds of things we develop for the Army, for example, off-road autonomy has fed back into our commercial business. So into agriculture, mining, and we just started to see this kind of flywheel start to take place. Now that we're in aviation, we're in maritime, we're in other domains, we fully expect that all this investment that we're making and the DoD is making and bringing us on as a partner into autonomy in those other domains, it's going to feed back into commercial just the same way. And so we'll start to see benchmarks while currently in the commercial space are going to starting to essentially take that flywheel effect, going back and forth.
Yeah, I spent my career before investing at Palantir, and a large reason why we were able to sell to customers like BP and others were, people liked that Palantir was the software that they used to find bin Laden. So, it made it easier to sell to some of these more traditional enterprises. So I think that flywheel effect
I think
is
it
real.
is also just a reality of technology, which is whether it's, Palantir or Applied or whoever, when you're working in a domain, you are compounding that all that software that's being written. So on our businesses, tools, operating systems, and autonomy, every year we're adding we do something like 1,000 features a quarter, which is kind of a mind-numbing number that's hard to understand. All of that benefits not one customer. It benefits all of our customers and all of our domains across both commercial and the defense side. And so, again, that's I think the power of dual use.
But from like a one level down, I get the building blocks are the same. You can share features, you can share things across. But are there any big technical requirements or fundamental product differences, things you have to build differently or build in one case and not the other?
Yes. However, so I'll give you a great example of a couple different products that we just rolled out. And so one is called Maritime Sim. So we do obviously a lot of simulation capability, all those tools for commercial automotive, run thousands of reps in order to find failure modes, et cetera. So we are working with the Navy on a couple different projects, and we wanted to basically build a maritime sim. So literally a virtual world where you have all the glint and all the sea spray and all of these things that you would experience if you were
in that domain.
Only in that domain. We went from zero,
horizon, just thinking about the fact that the horizon isn't straight,
the Earth is curved, right? The Earth is curved. All of these unique variables. But we went from zero, no product, to the first functioning use of a product in 5 weeks. It's all it took to essentially create that product. All because of the foundation that we have in our commercial space and our commercial tooling and the technologies, the approaches, and the talent. And we have these very talented engineers who never did anything for the military before. And then all of a sudden, 5 weeks later, we have the first version of that, and then are actually using, autonomy behaviors that we would actually put on a physical, unmanned surface vessel, running through that process right now.
Yeah, I mean, just in dollars and cents, our tooling that this is built on top of this maritime sim example is we've spent $750 million of engineering costs to build it. These tools are extremely deep. So the analogy really always ends up being is you have this base set of technologies which are then optimized for different use cases, and those use cases are different. So I think if you're taking a raw percentage of how much it is interoperable, it's vast majority of it. But for each of these domains, there is augmentation, and then even within the defense ecosystem, especially when you get to classified projects, there is there is some optimization that happens.
Yeah, and the punchline is the R&D is paid for by the commercial sector, right? Not by the taxpayer.
Yeah.
And so that's really the key for dual use technology.
Yeah.
And how has that affected just how you run your business in terms of who you hire? Do you segregate the company based on sort of I work on commercial or I work on government? How do you organize yourselves?
Not really. Yes and no. Obviously, we have a DC office, and the entire working with the DoD and the primes is just a different business.
It's a whole skill set.
You have that, but that's still a small minority of the company. But where there is a difference is you work in classified work. We as a company are a company of immigrants. So we have, Chinese nationals, we have Russian nationals. And so we have to be extremely organized, structured, and thoughtful about that. But it's absolutely possible. This is not in the realm of like, we need to like cordon off these engineers into one area or one building. Sometimes you have to, but a lot of times you don't have to. And so I think one of the, I would say, false kind of trade-offs people make is, all of this data or all of these tools need to be completely segregated and especially built for this. And it's like, actually, there's a lot more overlap than we think. And so, we do have processes, but it's smaller than you would think.
Yeah, and DIU, we were talking about DIU. I mean, the whole point of DIU originally was to build that bridge, rebuild the bridge between the Department of Defense and Silicon Valley. And, fundamentally, you've got to recognize that you need all of this work, to be developed, unclassified, most of it anyway, right? Most of the work can be developed unclassified, and then you can ship it into classified environments. That's exactly what we do. We obviously comply with all the, the rules of the government. But you have engineers in Mountain View who are working, for a product for a commercial OEM, for first half of the day, and the second half of the day, they're working on an Air Force project for us or a Navy project for us, for example.
Yeah. I mean, you just touched on this. There is obviously a huge push right now to modernize and improve the way the DoD procures technology, especially software. It's been going on for several years with DIU, et cetera, but it's definitely accelerated in recent months. And my question is, how is it going?
Yeah.
From your perspective as a company selling into the government, and what do we still need to improve, whether it's on the process side, on the culture side, et cetera?
I think a couple of things. Jason is closer to the ground here, but I think it's kind of like the stock market. If you zoom in, there's a lot of fluctuations. You zoom out, S&P 500 goes up and to the right. And I think overall there is improvements. Like we are not the same, we don't have the same challenges that even Applied sees from 5 years ago. So everything's gotten a little better. But I would say the high level point I would say is the more senior the folks who know software are in the Department of Defense, literally from even all the way from the President of the United States. How many levels do you have to go down before somebody really knows software and they were a software developer? The higher we can make that in the Department of Defense or any of the services, I think procurement will get better. So the knee-jerk reaction is to make procurement better, the process needs to improve. And that's like, another way of saying is in order to make the bureaucracy better, we need more bureaucracy, right? And so really what we need is actually the right people. When you have the right people at those senior levels who are, had practiced software development in technical, commercial, kind of industry, they can cut through a lot of that and they can say, that's actually a good product. This is not a good product. And they can streamline, the work. We see the same thing on the commercial side. Mm-hmm. In automotive, in construction, in the companies that you can literally measure from the CEO, how many levels do you have to go to where they really know software? Those companies are, you take a Tesla as an example, Elon knows software. So you're right at the CEO level, and therefore the product ends up being more software drenched.
Yeah, I guess I'll take a little bit more of a downer note, but then I'll come back to a much more positive note. I mean, if you look at the top 100 venture-backed companies that are doing business with the Department of Defense, and you take SpaceX and Palantir, put them aside, so now the top 98. That's $10 billion a year of business going to those 98. That's only one aircraft carrier, right? That's not a lot when you consider it's an $800+ billion, annually is what the Department of Defense is spending. So, roughly just over 1%. So that has to improve. And so a lot of the challenges, of course, are, and this is well known, it's well discussed, is just fundamentally the DoD focuses on hardware and they vertically integrate all the software pieces to that. That's starting to change. There's different programs, there's software pathways, there's a number of different things. Some of the behaviors of the various folks kind of in the trenches doing the acquisition, they need to be comfortable just going direct to a software company, specifically a product company. And a lot of people say, hey, we're a software company. They are a technology services company. They're not necessarily a software, a product company who knows how to scale from 1 to 10 to 100.
The nuance difference is when it's a services company, they're just going to charge you, the taxpayer, i.e. the government, per head. Whereas in a product company, you're getting that subsidy. You're getting that nice elegance of, hey, we're multiple customers are footing the cost of this, and therefore each of the customer gets a cheaper product.
Right. So time and materials versus product companies want to focus on firm fixed prices is this is where we're going to provide you. So some of that absolutely is changing, but it's still like steering the Titanic, trying to move in that direction. We just had the software pathways memo that Secretary Higgs just issued. That's like a beam of light. That's, like a hallelujah moment. How it's enforced is going to be very interesting. DIU can't do it all. Also, the capacity of DIU can't do all the software work. The services themselves have to learn how to do it. So there is absolute positive, progress on all of these areas, but long way to go for sure.
And maybe some advice from you both, from your experience with Applied, for other startups who are selling into the DoD. How important are partnerships versus building direct relationships with DIU and the services?
Applied's all of our values can be distilled to two words, which is radical pragmatism. So if you know people at the DIU and you come from DC, then go direct. If you don't, and you need a commercial partner like a prime, then do that. It's whatever gets you in the game faster. I think is important. I think though it's hard to have a real business in, let's say not only the DoD honestly, but also if you're selling to the government broadly, without really having a presence in DC with folks who come from the ecosystem, who literally worked in the ecosystem or were in the services themselves, because they really understand the business. It's like me going to the General Motors Institute for undergrad, growing up in Detroit, working at GM and Bosch, is the biggest tier 1 supplier in automotive. That informs many decisions. I think that's 20 years ago. There's many decisions today at Applied. So there's a similar version, copy paste on that. So
yeah. The first advice I have is always, as a company, no matter what stage you are, have a direct relationship with the government, with the actual government customer, and understand what that government, who the buyer is, who the users are. Have a relationship with them. With partnerships are a lot of work. I mean, they can be incredibly beneficial. We have a lot of different partnerships with different types of companies, different stages, venture-backed, some, public companies, big primes, that sort of thing. They're a lot of work. They're absolutely worthwhile, but you've got to balance out. You really need to have that understanding of what does a government need. There's oftentimes an opportunity where, we have an opportunity to go direct to the government on behalf of the partnership, regardless if our partner is much more well-established, much larger. There's just doors that we get into that they don't. And then, recently has been even more common, right? We're able to have a conversation with folks because of where we sit, because we're a dual-use venture-backed company. There's opportunities now that we have to talk through all these and benefit the partnership as a result.
Yeah, and that answer is honestly different between a dual-use venture-backed company versus, a research lab in Pittsburgh with 8 employees. That's going to be a very different answer. So I think we're heavily optimized for this venture-backed dual-use, kind of profile.
It's been, a wild 10 years or so in the world of autonomy, and we're starting to see, we talked about Waymo, the glimmers in the consumer space. It's coming. People are feeling that it's coming. Trucking and, more commercial industries, heavy industry, mining, construction, et cetera. The DoD, how we had our ChatGPT moment for autonomy. What do you think that looks like? Is that even possible?
I think the ChatGPT moment, just to make sure we're both talking about the same moment, is the fact that there is a broad consumer appreciation for the power of the technology. In that sense, no. I think you go to a suburb of Indianapolis or Kansas City, where people they're not living in the venture-backed or the DoD or the technology universe, and they're an accountant at a local, grocery store. They're not thinking about autonomy. They're thinking about ChatGPT. So that in that way, no, the event hasn't happened. Yes, the way the event has happened is if you go to anybody in San Francisco and in the automotive industry, there's no debate about autonomy. So I think it's different because, the way a chatbot and search information retrieval works on the web is just very different.
You can go to a web page a lot faster than you can buy a new car.
Exactly. But it will happen next 10 years. I mean, that is 100% of automotive OEMs globally are working on autonomy solutions. There is not a single OEM who does not have a real effort in the space. So all that means, and it's just, these are complex technical problems that are safety critical. The big difference between ChatGPT and a autonomy product is, one is safety critical and you're flying down the highway in a metal box going 80, 90 miles an hour. One of the, ideally 70, miles an hour. The one of the things that you don't realize, I started my career in safety in airbags is, when you're on the highway, you're also going 70 miles an hour. You get this false sense of security because you're belted in and there's like white paint on the ground, but you are just flying down the highway. And it's actually the most dangerous thing that you do by far every single day. There is nothing you're doing as dangerous as just getting in a car, right? I mean, what can we, we can have this interview and then we could be in a really bad accident 15 minutes from now. Like that's a crazy reality. It's also one of the reasons I think autonomy is so important just at a national level in terms of saving lives and costs of the suffering that comes with accidents. So that's all going to happen in the next 5-7 years. You don't need to go on 5 autonomy rides to be kind of blown away. And so I think all of that is coming. But it's not going to be like this one click.
And what about outside of me buying my personal self-driving vehicle in industry, whether it's in industry or in the government? How close are we to autonomy being ubiquitous?
I think I'm in government. I'll let Jason talk to about it within those contexts. Within construction, mining, ag, these other verticals, similar to passenger cars, where every major OEM globally is thinking about infusing this technology. And then broadly speaking, this kind of new modern operating systems in their vehicles to unlock a lot of these features. So there's no debate. There's not a single person in the vehicle manufacturing universe who works on technology that thinks this is not something we should be putting resources towards.
Yeah, you can look at Ukraine, for example, but even beyond Ukraine's been used as an example a lot. Look at the Middle East, you look at Yemen. All of this technology is fairly democratized, right? So it's kind of founded on a lot of open source capabilities and there's been an interesting, and if you really start to pay attention to what's happening like over Yemen, for example, like the Iranians have provided a loitering surface air missile system. So I used to be the director of intelligence for Air Force's Central Command. So this used to be this is a problem that I nerd out on, right? And so this is all like an AI-based, very cheaply made sort of weapon system that keeps shooting down our drones. And then the Houthis are launching these very cheap drones at destroyers who are shooting them down with these missiles that are $1 million a piece.
Yeah, and I think we can all say the Houthis are not like the most technically forward fighting force.
Absolutely not.
So you have folks who are not very technically advanced who are using fairly advanced technology.
Right, and so currently, most of these things that we've seen, like attacks on Israel and everything else, these drones come across, they're not networked. They're not really effectively networked. But the reality is that what is being exposed are new problems that all kinds of people throughout the world are trying to solve on this autonomy space, right? Collaborative autonomy, which is really kind of where all of the defense work is going to lean toward. Yes, for the U.S., but everyone else. It's kind of whoever figures out how to effectively network these swarms to where they can actually behave collectively, that is going to be what's
intelligence.
Yeah, and that is inevitable. That is an inevitable reality of where this technology is going. And so the first time that collaborative swarm is used anywhere, it's just a matter of time. That is just going to completely upend, if it hasn't been already, the entire defense industry globally.
It's an extremely exciting moment. What's next? What's on your minds? What keeps you up at night?
We're deeply technical company. Vast majority of our employees are software engineers. And so what's on my mind is, the culture within the company and making sure they're productive and they're pointing at the right problems and we're making progress on those problems faster than our competitors. And then, recruiting people. So if you're listening, this sounds interesting, whether you're on the technical side or on the commercial side, just on the business development side, we're hiring, so you can always reach out.
Yeah. I mean, one of the really cool aspects of our company is if you're curiosity, we have all these folks who are very curiosity-driven engineers who really love hard problems. We've got loads of them in a number of different aspects of developing software and doing various types of engineering to solve it. And then we also have just a lot of mission-driven folks who really focus on how do we get this capability in the hands of warfighters and in the hands of, governments, U.S. government and allies. And so you get this really cool kind of dynamic of all these people coming together. It's really neat to watch, all of them become like basically both curiosity and mission-driven at the same time. I've watched these, Silicon Valley-based engineers who had worked on, a lot of commercial products, like fly out to our site in Florida where we do a lot of flight testing for the Air Force, meet with a lot of our mission-driven engineers from our EPICI team, and then actually build something together that they hadn't built before, around collaborative autonomy. That's been really cool to watch. And that's, fundamentally, the direction we're going to keep going.
Amazing. Okay. Well, send engineers your way.
Yeah.
Yeah.
And thanks for having us.